Swayam Prabha. Digital India. Educated India.
Good morning everyone. Welcome back to our course on digital accessibility, and today we will discuss a little bit about emerging input technologies. So let us start with our current scenario and what are input technologies in general. Let's try to understand that first. So in a computer based system or an interactive system, usually the commonly known input devices can be your keyboard where you are entering text, your mouse which has a button or a scroll interface which helps you in pointing to or clicking in some onto some buttons. There can be graphic tablet based interfaces where there is a pen which is commonly called Wacom. The company Wacom makes graphic tablets where there is a pen based mouse, pen shaped mouse, and you can draw onto the Wacom tablet and it directly translates into a graphical digital drawing. Then there can be mic which captures your audio, biometric systems which can actually scan your fingerprints or other iris related things. There can be scanners which is part of your printers where it is almost like clicking a photograph of your paper or your document. There can be webcams which are basically camera based devices which capture live videos or helps you in video recording. Then there can be other devices like barcode scanners which help you, which is like an RF based scanners, and then they help you in scanning barcodes and QRs in real time very quickly. So these are some of the traditionally known input devices. Of course, the keyboard and the mouse are the most commonly, and the mic we can say are the most commonly used interfaces by most of us in our day-to-day interaction with computer systems. Then there is of course your mobile screen interface, which we are missing in this traditional landscape, is something which is a touch screen based interface. It can be a tablet, can be a phone, and that has capacitive touch where you can actually touch on the screen itself. So basically it's a version of a mouse where the screen itself is touch sensitive. So basically like a graphic tablet where there is an external pen and an external surface, or a mouse where there is an external device and then that device is rubbed or moved on an external surface where the movement is only translated on the screen. The same thing kind of translates in a capacitive touch based interface where your finger movements and your finger based pointer and touch is the cursor, is the pointer, and you can also do continuous movement scan. So basically you can draw on your phone also. So capacitive touch screens are one of additional input devices which we interact with on a day-to-day basis. So, traditionally the input technologies like keyboards, mice is a plural for mouse, just in case you are not aware, pose accessibility issues for people with motor, visual or cognitive impairments. We will have a deeper discussion about what kind of motor, what kind of visual or what kind of cognitive impairments would a mouse or a keyboard incur for usage. Motor impairments can make it difficult to use these devices, while visual impairments can be hindered by a lack of keyboard navigation or support or screen reader compatibility. We will talk about these aspects in a bit more detail. Cognitive impairments can be challenged by complex layouts and poor design, that can create barriers for all users, such as using unclear links. And of course, we have all experienced touch screen resolution and touch screen because there is a layer of capacitive, touch sensitive front on top of the LCD, that kind of reduces the brightness of the touch screen devices, and that is the reason we actually struggle to see the screens in bright daylight, right. And I think that is something we have all experienced, and that is a situational impairment. So, what are the issues with current input technologies? We will talk about them in primarily 3 heads. The first is motor and physical accessibility issues. So, motor impairments means dexterity loss or fine motor skill issues, hand paralysis or conditions like arthritis, where you are struggling to really hold bend your fingers in a desired format and keep pressing kind of buttons for longer durations, or fine motor skills. In fact, even when you are moving the mouse or you are moving your finger on the touch screen, there may be multiple buttons placed next to each other, and the pressing of the button assumes or requires fine motor capabilities. That means you are able to navigate your hand between 2 very close stimulus, right. So, such people with limited dexterity, hand paralysis, people who are aging or may have conditions like arthritis may struggle with the fine motor control needed. Alternative inputs are needed. So, we in our discussion so far, we have talked about this several times. When we look at multimodal interfaces, we always think about multimodal kind of input technologies as well, so that you have alternative ways to enter your input details. So, if I want to enter my name in a given field, of course, the first and the assumed way would be to navigate to the field first, probably using your mouse. Once the cursor is placed there, you are able to type your name. That is the base level interaction which is assumed, and then there can be other alternative ways. So, in case I am not able to interact with a mouse or a keyboard in an intended manner, there should be multiple ways to interact with the system to enter your input. So, such as people who are amputee, there are head pointers or eye tracking. So, right, how you look at the screen and where you are looking at, based on that the cursor is placed. The pointer does not require hand movements for the mouse. or switch access, which may not be supported by all software. So, basically we ideally would need alternative inputs, but that is not something which is supported by a majority of our interfaces. The third issue which is there is can be of limited navigation. So, interfaces that require precise mouse specific movements like drag and drop or complex gestures can be impossible for users with mobility issues to complete. Right. So, again precise movements, fine motor skills required, where you are supposed to click on something and drag it. So, basically what is expected is that you press a button, you keep it in the pressed condition in order to drag it and then release it. So, those kind of motor expectations all kinds of users may not be able to fulfill. The second category of issues with current input technology occurs in the domain of cognitive accessibility issues. So, under the cognitive accessibility issues, of course, there can be information processing related aspects. So, like individuals with cognitive disabilities like ADHD, dyslexia or other intellectual disabilities may have difficulty in processing complex information and navigating through confusing layouts. So, and following unclear instructions. So, if some instructions are given, but they are not precise, they may not be able to navigate through your content with ease. Then of course, this overwhelming interfaces, complex designs, frustrating and they create barriers, making it difficult to focus on the task at hand. This particularly is a major concern for the elderly as well. Then jargons and complexity. So, content that is overly technical or uses complex language can be inaccessible to those with cognitive impairments. So, we have looked at all of these aspects earlier as well, but looking at it from a input interaction perspective, we are trying to see what are the different issues in the current input technology state of the art. The third category of issues come under the assistive technology and software integration aspects. So, for example, screen reader is an assistive technology which is available and so called makes softwares and websites and apps accessible to persons with visual impairment, but if your software is not compatible, the architecture is not built in a way that a screen reader is able to access, the labels are not present, the headings are not present. That means it is largely incompatible with a screen reader, and even though assistive technologies like screen reader may be present in the market, they may not be useful for your product unless and until you make it compatible with a screen reader. And then there may be some complex kind of information such as tables or poorly marked tables which can get misinterpreted and misrepresented in a screen reader if they are not labeled properly. So, keyboard navigation problems. So, users who cannot use a mouse may be unable to navigate an application or website if interactive elements do not respond correctly to keyboard inputs. Then there can be dynamic content issues. So, dynamic content may include videos or live audios. If they are not properly announced using ARIA live regions, or they are not they are missing descriptive alt text, then they are largely not accessible. There can be some solutions. Some of these solutions might have already kind of come up in some earlier session, but this again, looking at it from an input interaction perspective and for special use cases, motor impairments, visual impairments, etc., it is good to have a discussion that way. So, for motor impairments, so like for example, with physical limitations and conditions like paralysis, arthritis, limited dexterity, make it difficult to use a mouse and a keyboard, and the solutions can be ensure that interfaces are fully navigable with the keyboard and that complex mouse specific interactions are not required. Right. So, things like drag and drop or very fine pressing of fine buttons or pixel level kind of segregation of information should not be there. Support for alternative input devices like head pointers or eye tracking systems can also be beneficial. So, if your software or your website is open to compatibility with other kind of input devices like head pointers and eye tracking systems, it's a great way to make it more inclusive. For visual impairments, keyboard navigation may be the only way to navigate, because keyboard kind of offers a very nice tactile kind of a layout, and the button islands are separated very nicely, and basically you can count buttons, or if you are an expert in keyboard usage, probably you will be very well aware of what is there in which region, and because it's a standardized tactile layout, right? Most of the keyboards are QWERTY keyboards, and the layout is standardized with so and so keys on the left, so and so keys on the right, so and so keys on the top. So then that is a very useful input. Wherever people with visual impairment go, they can use that keyboard. But if interactive elements don't respond to keyboard inputs, or if skip to main content links are missing, right. So, for example, there is the dashboard, there is a dashboard on top, there is an introductory tile on top on your website, there are many tabs on the website, and the moment you open this the website and the screen reader is also on, the screen reader starts reading from the top, right, but you don't want that clutter, that audio clutter, and there is no skip to the main content link. So, every time you open a page, that dashboard will get read every time you open it. So, having a skip to a main content links are very important, because if you are using it through a keyboard, it by definition becomes a sequential interaction. Mouse interaction, you can directly go and click to some arrow or some button, or direct the main content, you scroll down instantly as you land on the page using a mouse, but using a keyboard, all you can do is press tab, tab, tab. So, it may take like 15 tabs or 20 tabs to reach to the main content, which can be frustrating sometimes. Screen readers, websites and applications must be compatible with screen readers. This requires semantic HTML code level markup for elements like tables, etc., to ensure screen readers can interpret the content correctly. As a solution, make sure that you provide skip to main content links, ensure all interactive elements are responsive to a keyboard interaction. So, I mean, despite the fact that keyboard we are still talking about the traditional keyboard input means, and still most of the interfaces are not compatible with those traditional input devices. So, at a code level, semantic HTML needs to be implemented to structure content logically for screen readers. So, continuing on the same lines, for cognitive impairments, complexity is a problem. Individuals with cognitive impairment like dyslexia, ADHD may struggle with complex, overwhelming layouts. So, solution is that please design clear, simple layouts with straightforward instructions. Link text, always add links to the text. Ambiguous link text like click here or more information can be confusing. Keep it meaningful. So, for example, if the click here is meant to submit a button, it should be rather submit, or click here actually leading you to a table or a statistical diagram. So, it should be diagram here, right, instead of click here. So, that there is some meaning to the button, and then because the screen reader would also be able to kind of announce it that this button is for the diagram access. So, it should be contextual and it should be meaningful. So, use descriptive link text, etc., that clearly indicates the destination of the link. Then other general accessibility issues like dynamic content. So, for announcements for dynamic content are often missing. So, make sure that you use ARIA labels to announce changes to the users. Real world testing is a big barrier, and lack of testing with actual users is not really happening in a lot of cases. So, engage users with disabilities in the testing process to identify and fix accessibility issues in its core. So, this sets a bit of a background about what are the existing technologies in terms of input only technologies we are talking about. Right now, we are not talking about the output technologies. We will talk about the output technologies in the next session. Any form of interaction is basically that you are able to input some information, there is some processing and you get a feedback, or you are able to perceive a task and you are able to perform an action, right. So, both the input and output devices are there, and in terms of the POUR principles also, I think we have discussed this earlier. O, which stands for operability, which can increase the accessibility of any system, digital systems per se, is directly linked to your input devices. So, operability is directly linked to your input devices only when you are able to input your choices, you can respond to a call to action, you will be able to operate the system. Most of our current interaction looks like this only, and we have a screen with a lot of cluttered icons, maybe some background images, and then we are supposed to kind of navigate our way to the app that is needed and press it with our fingers. But this basically assumes a lot of abilities, and including cognitive, including motor, including physical, including visual, in the absence of which this kind of basic interaction also becomes a little bit of difficulty. So, most of our present interaction looks like this, where we have some icons, and we are supposed to kind of navigate our way to the app that we are requiring to use, and we then supposedly press the button. So, based on our previous discussion, Abhi, we have some idea that if you have cognitive impairments, if you have visual impairments, if you have motor impairments, physical impairments, then it becomes very difficult to do this basic interaction as well, right. And we also have spoken about several times that those impairments can appear in the form of a situational impairment as well, and may not be just limited to a permanent impairment. Some organizations like Apple have worked on iOS assistive touch, where there is an enlarged version of, it's like a lens which kind of goes around with your finger. It's not entirely for a permanently visually impaired person, but it can definitely help people who are elderly, in help in navigating or reading what the icon says underneath it, or pressing the right button, especially when they are placed so close to each other in a table format. People with cognitive issues, people with low vision, or people with low dexterity also. So, such kind of technologies are there which enhance or add a layer on top of your input experience and helps you in clicking the right kind of interface. That kind of builds a little bit of a background into what are the different ways now we are looking at in the future. What are the different ways to make input more accessible using emerging input technologies. Some of the aspects we had a discussion about in the AI and accessibility sessions, but here we will now talk particularly in terms of input technologies and how the emerging aspects can enable better multimodal accessible ways to interact with digital interfaces. So, emerging input technologies are transforming accessibility by offering diverse, personalized and hands-free interaction. So, this is very important. Personalized and hands-free and diverse, right. And now we will see in the upcoming slides how, in what ways it is personalized, it is hands-free, or it is diverse. So, these innovations are largely leveraged, leveraging AI technologies, sensors and robotics to go beyond the traditional keyboard and mice and providing greater independence of use and ease of use. So, let us see the different categories under which they fall. So, AI and machine learning driven inputs. So, artificial intelligence is primarily a driver in enhancing accessibility by creating more intuitive and adaptive input methods. So, First is something which may be very popular, which is something called advanced speech recognition and NLP, natural language processing. So, some examples may include say the dictate feature which we spoke about in one of the previous sessions on AI and accessibility. So, AI powered speech recognition has become highly accurate and speech based input and models driving speech to text, speech to text have become very robust. So, now doing a voice based search or dictating content to a Word to make a Word document, doing voice based control has become fairly easy. So, you can control devices, dictate text and kind of bypass. You can even issue complex commands and the systems are able to understand even if you tell them in a long form, long paragraph. They are able to semantically kind of summarize it and tell you what the action item and kind of squeeze the action item out of it and do it for you, right. The other aspects I think we did discuss about which needs to be looked at is probably speech based issues like stutter and all of those things, lisps, etc. But as the models are becoming more robust, those problems will, I am sure, get solved in the near future. The next set of kind of input devices which are driven by AI and machine learning are image recognition and computer vision based models. So, these technologies provide alternative input for visually impaired users. So, applications like Microsoft's Seeing AI or Google's Lookout use device cameras to recognize and describe objects, text, people in the surroundings, or converting visual information into audio feedback. So, basically you can wear your smart glasses and run these models and you can just you can just point your camera or just head onto a text and the image recognition models will be able to read the text for you and kind of convert it in real time into audio output. It can also be used in obstacle detection, real time obstacle detection to avoid kind of stumbling or banging into any object. Then predictive text and AI keyboards. So, AI driven predictive text anticipates words and phrases, significantly reducing the physical efforts required for typing for users with motor limitations. So, predictive text is similar to autocorrect, or when you write in the mail, in the Gmail, it based on the email, it is able to predict a response. So, something like thanks for the update or something like that, you do not even need to type any longer and you can just select one of those options and it is a faster and a more accessible way of interacting. Reduces the physical effort to a big extent. Then there are definitely AI powered virtual volunteers or assistants or systems like the one developed by OpenAI and Be My Eyes use AI to provide real time visual assistant where a virtual agent can see what a visually impaired person sees through their camera and provide guidance. Right. So, basically there is a virtual assistant who can attend meetings for you, can tell that okay, there is a room with around 15 people and so person is sitting on the right, so and so person is sitting on the left, which kind of adds to your social inclusion as well. Yeah, so something like a co-pilot is also an example of a virtual assistant. And dictate feature on Word, for example, is an example of AI powered speech to text input. Speech to text input, you can just dictate and make a document. There can be other alternative hardware input devices which are now being developed, the robustness etc. are being tested, and innovations in those hardware are now looking at different input methods for users with special needs, physical special needs. So, for example, eye tracking systems. So, these systems enable users with severe physical disabilities or motor impairments to control computers and mobile devices only using their eye movement. So, it also looks more natural. So, basically for a third person, it would appear that, so for example, here is my phone and I would also look at the screen and interact with it, right. Maybe I also require to use my thumb or my fingers, but for example, if those eye tracking systems are in place, I can just look at the device and kind of navigate through my gaze and select a certain option based on a longer gaze, for example. If a gaze stares on one of the options for a longer duration, it is able to open that. Then BCI or brain computer interactions, though still largely in early development or research stages. BCI, where you can directly control interfaces using brain waves. So, all you need to do is think, and that kind of bypasses all kinds of modalities, right, all kinds of impairments as well. All you need to do is think that this needs to be done and this button needs to be pressed and it will happen. So, that is going to be potentially a revolutionary hands-free input method for those with severe physical limitations. Then adaptive switch devices and joysticks. So, customizable input devices such as sip and puff switches operated by breath, specialized joysticks like those used in wheelchairs offer single switch or minimal movement control for navigation and task completion. So, basically what we are saying is that the older input devices like a joystick used to assume that you have again that dexterity and that hand movement, but say you have a person who doesn't have both of their hands. So, breath operated joysticks. So, if you sip, it is the car, for example, there is a joystick controlled car which is a breath controlled car. If you sip, then the car moves backwards. If you puff, it moves forward. Or specialized joysticks, especially for those who use wheelchairs. Then again a very interesting emerging assistive devices area is wearables. So, wearables, of course, I am sure most people might have heard about smart glasses. Then there are hearing aids which have like really evolved today's day and age. and other variables that are providing novel input and feedback methods. For instance, the ORCam II is variable device that reads the text aloud and is able to recognize faces also, and kind of tell you in an audio format that whoever so and so person is standing in front of you. Nimano robot gloves assist users with limited hand mobility in gripping objects. So, robotic gloves or haptic gloves are able to assist users with limited hand mobility in gripping objects. Then there can be new interaction paradigms, which are so the ones which we discussed earlier. There are more applications of AI or wearables or all of these other hardware technologies, but then there can be new methodologies itself which are coming up in order to drive these emerging input technologies and output technologies. So, gesture and motion control. So, the rise of sensors in mobile and wearable devices enables interaction through natural body movements, and this is being researched extensively for controlling devices without the traditional inputs, with applications in smart wheelchair and navigation systems. So, basically, for example, your phone now has a gyroscope, and there are other motion controls which are there, and even the same can be incorporated. Sensors, the cost of sensors, the cost of incorporating sensors has become very low. So, it can be something which can be explored in a lot of other applications like navigation. So, gesture and motor, gesture based control, where you are just indicating something instead of pressing buttons. You say, kind of swipe in front for the wheelchair to move forward, or you just swipe back, and the systems around the wheelchair is able to detect those movements and kind of help you in navigation itself. So, gesture and motion are one of the two key areas in which there is a lot of research going on. Then other hands-free interaction, a central theme across many emerging technologies is this hands-free interaction, which can involve voice-based input, gesture-based input, or the other alternative inputs like tongue movements, breath movements, which can address a wide range of mobility or situational impairments also. So, in the future it may actually look like that we are interacting with a robot, and we are just telling the robot to do things for us. The robot is able to decipher the semantic meaning of what we are saying and do actionable, is able to act accordingly. They have a robotic arm as well integrated in the system. So, if you think about all of these input technologies, if you combine them, it becomes a robot only. So, basically there is a camera, there is a microphone, there is a robotic arm, there is which can kind of fill in for the loss of physical movements instead of you. So, basically we are moving away from this kind of an interface to this kind of an interface in the near future. So, then this brings us to a very interesting video on emerging tech for accessibility. It's a longer video, kind of a TED Talk mode. You can watch it on YouTube. The link is right here on the slide. I can play it. A little bit. So, basically, Joe Devon is talking about the future of technology and how it runs through accessibility. A lot of the developments are happening in order to address accessibility issues, and then eventually all of those things will move into broader consumption and no longer be specialized technologies. And that is the basically the premise, overall premise of the talk and the interaction. You can go ahead and watch it, it's almost 50 minutes. And I hope you gain something from it. So, in order to summarize today's session, we want to say that emerging technologies, when developed with inclusive design principles from the onset, they are vital for breaking down barriers and ensuring equal opportunities for individuals with disability in an increasingly digital world. Right. So, more of our interactions are becoming digital, and how all of these digital interfaces can enable wider access is something of key importance and criticality in the current hour. So, some of the search topics that you can utilize for your for gaining more insights on this topic is emerging input technologies, AI based input technologies, wearable input technologies, adaptive input technologies, etc. And we will talk about emerging output technologies in the next session. Keep learning, and let's see you in the next session. Thank you for joining.